Thank you. My name is Herman Balsters, and I'm going to talk about modeling today. I'm going to say something about how you model processes and how you can derive data models from process models. And then the really nice thing is how you can generate code from these models. As I already said, I have a background in mathematics, computer science, mostly an academic background, and I'm also an associate professor here at the University in Groningen. And the last years I've been trying to trouble myself, trying to get my academic knowledge to also be something useful. And so what I've been thinking about is how do you translate all these nice models that we have? How do we get them? How can we actually generate code from these models? So what I'm really trying to do is revisit the old model-driven approach that was introduced in the 1990s by the object management group and try to breathe some new life into this model-driven approach and actually do something with it. So what I'm going to do today is tell you something about how we do process modeling and data modeling at Contracts 11, which is a startup company here in Groningen. And after my talk, my colleague, Henk Doornbos, is going to get into the technical details of how you actually do the translation, how you get the process models and the data models, how you can compile them into Python and into PyDatalog. First of all, you have to realize that there is a problem. Many ICT systems don't work. Many large ICT systems do not meet end-user expectations. Not too long ago, there was a large parliamentary inquiry here in Holland trying to investigate why so many large ICT projects in government fail. And it was a shocking conclusion that on an annual basis, the Dutch government loses about 5 billion euros in failed ICT projects. And this parliamentary inquiry showed up that one of the main reasons why these systems failed was that the flaws only show up after delivery of the system. Expected functions of the systems are not provided, and offered functionality is not wanted. So what you get is what we sometimes call perfect failures. Technologically perfect, yeah, but they're not used, so you can just throw them in the garbage. An example of notoriously non-functioning, failing systems are these electronic patient dossier systems in hospitals. You constantly read in the news that these systems, they're delivered, and then when they try to use them in practice, they fail. We're talking about systems that on average cost 50 to 100 million euros. And this is happening on a large scale. If I give a percentage, I would estimate about 80% of the EPD systems in practice, they fail. So, initial designs of the ECT system do not match end-user requirements. That's actually what is the case. So we're trying to do something about that. We're trying to find out how we can actually capture the requirements of end users, of domain experts, in a consistent and complete manner. And not only that, and just don't see that as one separate phase and then just try to develop the code after that. No. When you have your models have to be that complete and that precise that you can actually compile those models into code. So you could also see these models as a very high-level programming constructs. Like I said, the MDA, model-driven approach, was first introduced by the object management group. Yeah, you can also say, oh my God, and a lot of people think that when they hear the object management group, think, oh my God. These are the people that have forced UML down our throats, for example. The claim was originally that you could start from high-level UML models, process models, activity diagrams, class diagrams, and then this was the dream. You could generate Java from these models. Well, the claim was never fulfilled. It was just more of a heuristic, than an implemented procedure. And what we're trying to do is revisit this idea, which is a nice idea of the model-driven approach, and see how we can actually compile code from high-level models. One thing is very important. You have to understand that data in itself, data modeling is extremely important when you're trying to, especially build database applications. Data cannot be seen as something that is loose, that is separate. It is always relative, and it's always relative to its context of use. And there was a famous philosopher, Ludwig Wittgenstein. He also said, he was the first one who said, well, look, data is not an absolute thing. And you don't ask for the meaning of data, but you ask for its use. When you see its context of use, then you all of a sudden see how data gets alive and what it means. So our context is a business process model. Yeah? You're building software because you're building it for somebody to use, and that's inside of a company usually. And so what we do is, our starting point is some business process model. And what we try to do is, once you have such a process model, how do you also derive a data model that fits that process model? Yeah? So what we do is we start from the process model, and then we try to tailor-made, we try to get data, derive data that fits that process model. And that's the starting point for our generation of software. But the thing is, why can we succeed where the original model-driven approach fails? Well, first of all, your models have to be precise. And this is where the original MDA fails because, well, anybody who has any experience with UML class diagrams know that they are notoriously ambiguous and really hard to read. And actually, they can be considered as a failure in practice. What we do instead is we use a specific kernel of business process modeling notation, by the way, also introduced by the OMG, to precisely model our process. And then we use a data model, which we have coined OLE, which stands for Object and Logic-Based English, which is highly expressive and very precise. And both the process model and the data model can be used to compile, and in our case, we compile to Python and to PyDatalog. The second principle is that you have to realize that correctness, when you deliver software, correctness is end-user correctness. Yeah? The end user is the domain expert. Yeah? And if the software does not provide the desired functionality of the domain experts, then you know that the delivered software will fail. So what you have to do when you design is you have to be very careful to capture the domain experts' requirements, yeah, in a consistent and complete manner. And that's a very, very hard job. So you have to figure out what does the business process look like and what's the business data look like that supports that business process. So this is the important part. How do you validate a model? Anybody can write a model, but how do you know that your model is correct? Well, if you ever tried to present a domain expert with a UML class diagram, well, you know, that's just impossible for anybody who has no technical feeling, and even somebody who does have technical feeling. Nobody can read UML class diagrams. Extremely hard to read, very hard to write, and to get them correct. So class diagrams are really quite useless, so we need something else that's better. And what we did is we tried to build a data model, not using graphical notation, but using a structured natural language. Why do we do that? Using structured natural language, you can just present to somebody who does not have a technical background, and you can present this model to that person, non-technical domain expert, and ask him, is this correct? Is this a correct representation of your needs? So that's one thing. You can start building models, process models and data models, and then what you then have to do is you have to try to debug your models in a systematic manner. Because it's extremely hard to get user requirements right, especially you can't get them right in one go. You have to go through a number of cycles in order to capture the end user requirements. So what you're trying to do is you're seeing your model as something you have to constantly attack. Yeah? Trying to figure out what's wrong with the model. Is it consistent? Have I understood my domain expert correctly? Did I get all of his requirements? So that's a really hard job. But once you go through this systematic cycling of attacking your model, at a certain point, your model starts to converge, and it becomes stable. Then you find out that your domain expert is satisfied with what you're telling him. Yeah? And then, once you have an accepted model, then you know that if you build software according to that model, that you have a guarantee that your domain expert is going to be satisfied. Yeah? So you're putting a lot of effort, a lot of time in trying to capture the needs of the domain expert before you actually start coding. So another famous philosopher, is Sir Karl Popper. He said, a theory is just a hypothesis that is in need of constant falsification. And that's what we're doing. We're constantly attacking our models, trying to falsify them. And once we do not succeed in falsifying our models, then we know that we have something that's going to be accepted by the end user. You have to know that when you're modeling, what you're actually doing, you're just making a lot of assumptions. You're making a lot of assumptions as a modeler about what the domain expert wants. Yeah? And therefore, because there are assumptions that they're in your head, you have to systematically challenge your model. Yeah? Are the assumptions that I'm making about the domain expert, are they correct? And if your model is wrong, your software is going to be wrong. So you really have to attack your own models. You have to try to falsify your models. What we do is we use an agile approach. We model our process and data, we prototype the model, and we use feedback from the domain expert to systematically falsify our prototypes. And if you go through a number of these loops, a number of these feedback loops, a number of cycles, then eventually you'll get a stable model. Your prototype is now turned into an implementation of the desired system. Well, how do we do it? Well, in order to have models that you can actually use as a starting point to compile to actual code, you have to have models that are not only precise, but they also have to be expressive. So what we use is, we use business process modeling notation, an international standard, has good tooling. For example, we use Visagi, has very many modeling primitives, almost 200, and actually that's quite a drawback because not all of those primitives are that essential when you're doing modeling. In a model, you're trying to capture the conceptual essence of what the domain expert wants, and you don't want to be driven at that stage by implementation details. So many of the primitives in BPMN are actually implementation driven, and what we do, we have selected a set of what we think of 8 important conceptual modeling primitives. So, a business process consists of a collection of pools. Pools are divided in swim lanes, and each swim lane is associated to a stakeholder who's responsible for a certain function that has to be realized. Processes have one main start event and can have many stop events. The process consists of activities ordered in sequences. Activities can lead to gateways, and they can split in 2 or more activities. They can be nested, and pools communicate through messages. I'm quite sure that all of you have seen some kind of a process model that abides to these constructions. An example, what we have done at Contracts 11, we've tried to offer a solution for a problem that a notary, in Dutch notaris, a notary had. He wanted to have one of his services automated. And this service concerns striking out mortgage certificate registrations in the Dutch Land Registry Office. So when somebody buys a new house, for example, then his old mortgage has to be striked out. It has to be canceled, it has to be removed in some way from the Land Registry Office. Well, this job is experienced by the notary as cumbersome, dull, and very time-consuming. And what we did was we tried to design a system to provide this service for the notary. So what I'm going to show you now is the process model that we came up with to describe this, at first sight, quite simple situation. I'm not going to explain this process model in detail. What I do want to say is that, of course, we did not write this model in one go. It took us a few weeks to specify this model. What you see is you see different swim lanes in different pools, and the pools, they communicate. The rounded rectangle are activities. The red dots are stop events. The green dots are start events, and there's also a main start event. And these pools, they communicate through messages. So what you see here is, for example, you see a pool at the bottom, which represents activity that is being undertaken by a bank, and then the next pool is activity that's undertaken by a notary. What you also see is that this has been written in Dutch. What we also try to do is when we write our models, the process models or the data models, we try to use as much language as we can, and we don't like to get too much entangled into graphical details. What we have experienced is that non-technical domain users have no problem whatsoever trying to learn BPMN. I mean, I've worked with doctors, with notary, but also we're also working with people who are trading alcoholic beverages, and they also want to have a system designed to help them trade, to improve their trading system. These people have never seen BPMN before, but after a session of about a half an hour, you explain to them how a process model works. It's surprising, but they get used to the notation very, very simple, very, very fast, and they can also, what my experience is, they even start pointing to the model and say, hey, there's something wrong there, or there's something missing. So they can easily actively get engaged in your process modeling. So what you see here in these process models are, like I said, activities. Activities are ordered. The diamond-shaped things, those are gateways, and those are tests to say you have to make a decision. You either go one way or another way, well, etc. This is how this works. Yeah? So that you get a flavor of what the process model looks like. Okay, like I said, this is not something that you can just write down in a very easy manner. You have to constantly talk to your domain expert. You have to try to find out, what he wants. Yeah. So you make initial models, and then you systematically cycle through that model, and you get more and more detail. You constantly have to validate against the domain expert that you have understood him correctly. And then after a while, the cycles start to converge to a stable model. Actually, each model, each business process model starts in the same way. And this is the highest level that you start with. It all starts with what we call a high-level happy flow. It starts at the green and it ends at the red, and in between you have 3 stages. The first stage is what we call coding, and that's where you have to massage the input in order to process the input. Sometimes you have to reformat the input, for example, or something's coming from a different database, and you have to reformat it before it fits into your own database. So you first have to massage the input sometimes before you can actually process the input. Then you transform the input to the output, and then you decode the output. Sometimes the output, which is delivered by the system, is not readily available for consumption by the environment, so you have to perform some extra tricks. But basically, this is all how it works. And then what you see inside these rectangles is a plus, and that means this is a nested activity. That means that this is from the top-down approach that we use. We zoom into this activity, blow it up, and get more and more details. And each time you go through the cycle, you get more details and more details. Well, that's only one side of the coin. That's process modeling. The other side of the coin is data modeling. A system is only complete when you talk about the process and the data. Now, what we try to do when we are capturing user requirements from our domain experts, we use an approach called fact-based modeling. When things really get tough, you have to be able to provide data models as a blueprint for a database, and these data models have to be very, very precise and reliable. Then in the data modeling community, there's an approach called the fact-based modeling approach, and that's been extremely successful in coming up with data models that are precise, and also extremely expressive. In fact-based modeling, we talk about objects and facts. And facts are sentences that are either true or false. And facts have various properties constraining data in the database. So we're talking about uniqueness constraints, keys, foreign keys, set comparison constraints, and things like that. FBM is a well-established approach in the data modeling community. For example, an organization that uses FBM is the ESA, European Space Agency, and the satellites that they build, of course, have to conform to very, very high demands, and they use the fact-based modeling approach to model the data for their satellites. And one of the main advantages of the fact-based modeling approach is that the models can be validated because everything is specified in terms of sentences. And you can validate the truth or the falsity of a sentence. And if the model is written in such a way that a non-technical domain expert, can actually read the model, then you have an excellent means of capturing the correctness of the model. So what we use is what we call OLE, Object Logic-Based English. It's a particular flavor of fact-based modeling. And OLE is a structured natural language that can easily be read and written by non-technical domain experts. Our experience is that these structured natural language models are much more suited to capture domain expert requirements than graphical diagrams. Yeah. At the same time, these structured natural language constructs are very precise, very expressive, and actually you can see OLE as a conceptual form of a data definition language. What we also did is, it's not just data modeling, of course, but we're also doing process modeling. We've extended this OLE language, which was first just only about modeling a database. We extended the model with process primitives like trigger, message, test, activity, things like that. So when we present an OLE text to a domain expert, we're not only asking him something about data, something's going into a database, but we're also asking him if we've understood the process that he's involved in correctly. So the ordering, the decision that you have to make, do we start here? And if we start, what triggers that event that we are getting into? So we're validating the whole system, but then on the conceptual level. What we then do, once we have this version of OLE, which has the data aspects and the process aspects, then we can compile that into Python and PyDatalog. And after my talk, Henk Doornbos is going to say something about that, how you actually do that compilation. This is an example of an OLE spec. As you can see, it's more or less structured English, but it's structured. Yeah, and it's expressive. And when you're talking about data that's going to go into a database, well, you have to know how to identify the data. You have to know which constraints apply to the data. In our case, we also want to keep track of things like messages and tests and things like this. So this is an example of a message, how it's coded into the OLE language. So we say the message is identified by a certain number, there's a certain sender, there's a recipient, it's about a certain topic, it's received on a date, and there's also an event that led to that message. This is the basic structure of messages in OLE. And you also see things like, in this case, LRO, that stands for Land Registry Office in Holland. That's also an entity. We model that entity as well. And we look at those data elements inside the entity, Land Registration Office, that are relevant to our particular application. This is an OLE specification of an activity, and this one is about making a cancellation statement, because what we're trying to do is we're trying to strike through these mortgage certificates in the land registry system, and we have to perform a certain activity, and when we specify activities, we have to say how they're identified, is responsible for this activity, and that also means, of course, that the one who's responsible is the stakeholder in charge of the function that is related to the swim lane in the pool of the BPMN model. There's a timestamp on it, and you also have to say that an activity provides something, yeah, it results in something, produces something, and you also have to say what invoked that certain activity. So in this case, we had a start event which triggered this activity, and that's specified in the 3 lines below. Now, I'm not going to go into more detail in BPMN and OLE here, because what I want to do is give you the flavor of how we present models to our domain experts. So we give them BPMN models, we give them OLE models, and first we start very, very simply, very high level happy flows, very simple data models, and then gradually we introduce more and more detail into the process model, and then we derive the OLE data models from the process models, and then once we've cycled through that whole process a number of times, we eventually converge to a stable model, and each time we go through the cycle, we also try to prototype the combined process and data model. Okay, so this is, for example, code that we get from after we compile the process and the data model, and Henk Doornbos is going to say a bit more after my talk about how he does this. Well, one thing in my title was contracts. Yeah? Well, all I want to say is that one thing that we want to do in Contracts 11 is, well, do something with contracts. Contracts are specific activities relating to an offering party and a requesting party, and of course contracts are built by employing strict rules in the order in which activities are done, and also constraints that are placed on those participants that are involved in the contracts. So what we want to do in Contracts 11 is we want to that's our dream, is we want to provide an automated environment for closing contracts in a distributed peer-to-peer network. That's what we really want to do. Nowadays, like we already talked about the notary, there's always an in-between party that we need in order to draw up a contract. What we want to do is we want to provide automatic means for drawing up contracts in a peer-to-peer network. Yeah? So we're just starting now to realizing that dream. How do we do it? Well, we do it using BPMN, OLE, and Python. Our basic idea is that contracts are built up from small initial building blocks, and that from these building blocks we can use certain combinators, and when we combine these small building blocks, it's most simple contracts, so we can get more complex contracts. What we're actually trying to do is we're trying to devise an algebra of contracts. You could also say that we're trying to come up with a recursive definition of the concept of contract. And we're investigating that, we're researching that at the moment, and we think that BPMN gives us the right kind of primitives, yeah, that we can use to combine small contracts into larger contracts. Yeah? So what we're trying to see is how a BPMN model can represent on the process layer what a contract should be. And of course, you need a lot of data in a contract, and we think that OLE will offer us the precision, yeah, and the expressiveness to model the requirements that pertain to contract. And furthermore, once we have this in BPMN and we have it represented in OLE, we want to compile the whole thing to Python and to PyDatalog. So this is our statement of strategy and means. So this is my talk. Yeah, this is what I wanted to tell you. What I wanted to say is that data in itself does not have much meaning. Data only has meaning within the context of its use. And for us, the context of use is a business process. And then by systematically cycling through process models and deriving data models in OLE from these process models and constantly prototyping what we have in each cycle, yeah, then we can eventually, yeah, get to working software that is acceptable to end users. So, this is my talk. Thank you very much. Are there any questions?
Yeah, I have a question. I'm curious, how do you convince people to work according to the system? Because it sounds amazing. I think it takes more time. I think the startup takes longer. Normally, you talk to the customer and you start coding.
Yep.
You're very happy because you started coding.
Yep.
And I'm very unhappy because you built something you didn't want.
Yes. You're right when you say that it takes more time, yes, but it's time well spent. Because you see, what you do is you have to, of course, you have to convince your domain expert that it's also worth his time. Yeah? So does process modeling in BPMN, will that appeal to the average domain expert? Working with OLE models, does that appeal to the average domain expert? Well, in our experience, yes. I've used these models on a large scale, and my experience is that non-technical domain experts really like business process models in BPMN. Like I said, they get very enthusiastic and they start pointing out, faults in my own models, like I think there's something wrong there. So they find out it's easy to read, yeah? And some of them, when they really get enthusiastic, they start learning the process modeling themselves, and they actually offer suggestions for processes. Data modeling is a bit more difficult. Of course, any of you have experience with data modeling know that data modeling that can be quite hard to do and very subtle. But once you have convinced the person, the domain expert, that what you're doing is eventually going to get him the software that he really wants, and he's not going to be disappointed by investing the time and energy in this modeling phase, Well, that's where you book your main gain. So yes, it takes more time, yes, but it's time well spent, because once you have the model correct, yeah, and Hank's going to show you, Hank Dorf's going to show you, you can just compile the code from the model. So the model is actually high-level programming, yeah, and then you're compiling it to lower-level programs. And what you're not doing anymore now is making a clean cut between the modeling exercise and the programming exercise. You're actually compiling from the models to the code. Yeah? So what we're really trying to do is revisit, put new breath into the life of the model-driven approach. Yes?
Also, I think it's about to mention is that the experience that we have is in the development. And if you tell the customers, it's obvious upfront that when you talk, what appears to them as a simple process for which you try to write software, they start realizing the process is not more complex than the intelligence.
Oh, yes.
So like the notary, but in the issue of all that simple process, how hard can it be? And then you start modeling it together with the notary, and then you dive more within it, and then you start to realize oh, it's more complex. So what normally happens is that you start writing the software, he doesn't realize how complex the process is, and then you say, wow, it's really complex software, blah, blah, blah. Then you can explain why the software is not doing what he did. Well, in this case, you're actually experiencing with him at the first moment, this is how complex it is, once software for this, it's going to take time.
Yeah. Yeah, our experience is that we actually teach domain experts what their process looked like. Yeah, so it looks like. So like the notary, you know, when he found out that, you know, when we wrote the BPMN model, he said, wow, I didn't know it was that complex. But what you're trying to do, of course, is you're trying to get activities that are done by a human, yeah, you're trying to get it into a machine. Yeah, you're trying to program a machine. So if you're trying to get all the activities that a human does, his decision making, if you put that into a model, then you find out, hey, this is a bit more complicated than we thought. And what we also found out is that when you talk to domain experts and you model, you also invoke discussion among the domain experts. Because, for example, I had two domain experts and I was interviewing them. It was about building a system for trading goods. And I said, well, how do you perform this particular activity? And then one domain expert, oh, I do it like this. The other says, oh, do you do it like that? I do it completely differently. Yeah? So, and then after this discussion, you know, the three of us, me as the modeler and the two domain experts, we had to converge to a model of the activity that was going to be representative for that aspect of the system. Yeah? And the domain experts really like these discussions, yeah? Because they actually learn from these discussions. They learn about their own processes, they learn about their own data. And the thing is, when you're talking to them like that, they also get more confident that you're going to build software that's actually going to conform to their user expectations. So it's time very well spent, especially when you tell them that after you've done the modeling, you press the button, you can compile the code. Yes.
Yeah, so you have built software for the notary, and after 6 months he comes to you and says, yeah, the law has changed.
Yeah. Yeah, that's a very good question. Yeah, very good question. So how good is this modeling technique when it has to be adapted? Yeah, when you're forced to change it. Well, what we do is we see where the change that is requested, where that has an impact in the model. So apparently something in the business process has changed. So we identify which part of the process needs a change. We change the process model. Yeah. Then we change the data model that is associated to that part of the process model, and then we just compile again, and then we get the new situation. So actually, what we have is we have a very flexible and also a sustainable solution, because all we have to do is pinpoint, isolate that local part of the process that is affected by that change, and then we just compile again. So all of our changes run through the models. Yeah? So we don't change the code, no, we change the model, and then compile again, and then we get new code. Yes?
I remember all day in data modeling on one of your master courses. I took 2 years, I think, for that. But what I also remember is that every time I had to change the models, it was actually easier to write SQL, put one of your tools, and then generate the OLE and graphical data graphs. Why? Because changing models in OLE and graphical is not that easy. Maybe because I'm a software developer, so it's kind of...
Well, our experience is different. Our experience is that you have to start from the process model because you have to understand what the change actually is. Something has changed in the business process model. So you have to first really understand what the change is, what's the definition of the change. And then what we do is we can from the BPMN, for example, Henk Dorl is going to tell you, we can generate 80% of the new data model, generate that. Yeah? From the changed process model. And then all we have to do is fill in the extra 20% by having an interactive session with a domain expert.
But my statement is that if you take the model before that and after the change, and just take the OLE definition of that, just not one, and just compare it, you will see that like 30% of the OLE definition will change. And if you don't use some tool for that, you will have to write it by hand. So it's like, why use OLE if you can easily use SQL?
Because SQL, you see, it's all about validation. You said, why use OLE when you can use SQL? Domain experts can't read SQL. Yeah? So what you're doing, OLE, the most important thing about OLE is it offers you a validation facility, yeah? So that the domain expert can tell you whether your changes are right or wrong. Okay, so I have to stop here.
I'm afraid we're out of time. If you have any more questions, I'm sure Herman will be glad to answer them outside of this session.
Yes.
Thank you very much.
Okay, thank you.
Very interesting talk. And as a token of appreciation,